It's recording. Yeah.
Okay, thank you so much. Well, welcome to tonight's presentation on Warriors of the Rainbow Coping with Climate Change with our guest, Dr. Steve Lanoux. I just wanted to go through some housekeeping advice here, ask questions in the chat during the presentation, and we will get those answered for you as at the end of the presentation. If we can't, we will be covering the answers in a post-workshop email. The links to the slides will also be shared in that email and at the end of this presentation. Thank you in advance for coming here, for your respect, your charity, and your positivity in bringing this topic to the forefront of our hearts and our minds this evening. So without further ado, I'm going to introduce our speaker, Dr. Steve Lanoux, who was born and reared in New Orleans. He holds a Bachelor of Science in Zoology with focus on marine ecology and biochemistry, a Master of Science in Organizational Development, and a doctorate in Human Systems Management. He served 25 years in the U.S. Navy surface ships, and after retiring as a commander in 1993, he was appointed as Assistant Director of the University of Texas Marine Science Institute in Port Aransas, where he and his wife live, Port Aransas and Brownsville, right? He was responsible for all operations on 3 campuses and was the Marine Superintendent over the research vessel fleet and the University Marina. Aside from this, Dr. Steve also is a Texas Master Naturalist and a Texas Master Gardener, and this presentation is given in part with thanks to the Texas Master Naturalist and as a water specialist by the Texas Parks and Wildlife Department. Thank you. Oh, and when I met Steve, I know this is a project that's very close to his heart, is being the chair of the Texas Tropical Trail region, one of 10 regions in the state that promote heritage, tourism, and historical preservation. Thank you so much, Steve, for joining us this evening, and please take it away.
Thank you, Nikki. Without further ado, let me get the share screen going and put the presentation up, and we'll get rolling. Let's see. Are you seeing my screen?
Not yet.
Not yet. Okay. Screen.
Something changed there.
There we go. Okay. So, Warriors of the Rainbow. And at the very end, I'll tell you how we came up with the name Warriors of the Rainbow. But I want to give you the background to that there. First, I got to do a couple of disclaimers. I'm not a climate scientist, but then I'm in pretty good company. Neither is Greta Thunberg. So why am I here? Like Nikki said, 25 years in the Navy around the world, been through hurricanes, typhoons, tropical storms. When I was with the Marine Science Institute, it was part of Arctic research, including effects of shrinking sea ice on climate. And I've got a few certifications. But the reason I'm here is because Nikki asked me to be here. So that's why we're doing this. Big picture is climate. Climate's global. It's fairly long term. It's not a snapshot. Weather is what's going on outside your window right now. Some of this is very basic, and I'm sure you know it, but we'll do a little bit of a refresher as we go along. We've seen a lot of the headlines from papers around the world and around the nation as to what's going on and the heat domes and a lot of us it's affected personally. Bad news slide number 1. Climate's change is happening faster than we thought it was. It's having more severe influences. I mean, look at this. This is scary. In Paris, mortuaries are being overwhelmed by people dying from the heat. So that's an unforeseen influence. The scientific process, it takes years to collect data, and then you've got to compile it, and then you've got to get your colleagues involved. You have to write up your paper, then you've got to get it validated with peer review, and then finally you're able to publish. By the time you publish, things have changed. So you're trying to take a photograph of a moving target, and it's just very difficult. There are some benefits, but the negatives outweigh the benefits. All of the models are imperfect, even with the advances of artificial intelligence. And AI does some weird things to some of the models that make them less reliable than they were before. Also, climate scientists tend to come up with global solutions that are not necessarily appropriate for all parts of the world. So climate scientists themselves are part, but not much of the problem. I'm not going to sit here and tell you that humans are responsible for all of climate change, because there are all of these cycles that are going on, and as they cycle, they overlap. Sometimes they cancel each other. Sometimes they enhance each other, and none of them are fixed lengths of time, and you don't know when they're going to end, when they're going to start. So trying to figure out a model that takes all of this into effect is doggone near impossible, even with the supercomputers that they have that they're applying to it. And then, of course, there are the unforeseens. There's the volcanoes. For example, when Mount Pinatubo exploded in the Philippines, it lowered the temperature of the Earth by almost 1 degree centigrade for 2 years. And then, of course, there's things like very large-scale meteor explosions that can have significant effects on the climate for millions of years. This shows the last 800,000 years or so of climate change. And right here, about 20,000 years ago, is when the last ice age was. And if you take a look at the scale, we're only about 10 degrees centigrade above where we were during the last ice age. So it doesn't take a lot of change. When climate scientists talk about trying to stabilize everything at 2 degrees centigrade, it doesn't sound like much, but you can see that that's 20% of the way to another ice age. So it's fairly large. If we zoom in onto the last 1,500 years, you can see that there's generally been a downward trend until the beginning of the Industrial Revolution, when all of a sudden things started to go rapidly in the upward direction. So what we're going to take a look at for a few slides is this part, the instrumented period, where we have fairly accurate measurements of temperature around the globe. So this is what that looks like. And it's kind of scary. And also for the climate change deniers who say that man has no effect whatsoever on climate, this part right here is World War II. This is the Korean War, and this is Vietnam War. So it's pretty obvious that human beings can have significant effects on the climate in short term. But this is what the aggregate air temperature, and since the air is in direct contact with the surface of the ocean, not surprisingly, the sea surface temperatures look exactly like the air surface temperatures. So there's air and there's the sea, and they look exactly alike, including the World War II and Vietnam War effects. The reason that sea surface temperature is important is that warmer water holds less oxygen. So species that are oxygen sensitive can be placed under stress in the oceans by the warmer air. The other thing that's even more important is that warm water expands. So this shows from the beginning of our instrumented period to about today, what's happened with sea level rise based on the thermal expansion of the oceans. So Miami and Maryland and Brooklyn, I hope you take note of this, that we need to do something about it. Now, scientists were trying to figure out what was going on, and then they discovered that if you take carbon dioxide, and that's this black line, if you take the concentration of carbon dioxide in the atmosphere, it almost exactly mirrors the rise in the temperature. Now, the statisticians will tell us that correlation does not mean causation. Yeah, but it's a good clue and it's a place to look. And then by doing various other research and using other kind of modeling and experiment in the laboratory, they're able to prove that carbon dioxide is in fact the greenhouse gas that's primarily responsible for this change, along with, of course, the effects of the other cycles that we're seeing. So, carbon dioxide. Let's look at some of the stuff that goes into the atmosphere and where it comes from. And these are the major sectors of the economy, the global economy, and where the atmospheric emissions come from. Some of this we have little control over, some of it we have more control over, but not total control. So I want to take a look at a couple of our favorite things. Let's take a look at transportation, our favorite, the vehicles. So this is the stuff that comes out of the tailpipes on our vehicles. We got some really nasty stuff, nitrogen oxide and hydrocarbons that are carcinogens and toxic themselves. Of course, our friend CO2, carbon monoxide, and sulfur dioxide. A catalytic converter takes most of this really nasty stuff, the nitrous oxide, carbon monoxide, and the hydrocarbons, and converts it into another buddy, carbon dioxide, nitrogen, and water. These two are benign, but as we have seen in the previous graph, this isn't. So we're actually doubling up on our carbon dioxide, but we're not getting this kind of stuff coming out of the tailpipe. So it's a little bit of good news and a little bit of bad news. Here's another bad news slide, number 2. Doesn't make any difference whether you're burning gasoline or you're burning diesel fuel. The product in carbon dioxide is 3.2 times the weight of the fuel. So you get, for a gallon of diesel fuel, you get 22.4 pounds of carbon dioxide coming out of the tailpipe. So the math is kind of shaky, but you have to remember that when you're burning this fuel, you're taking all these complex hydrocarbons and converting them into carbon dioxide. It kind of, when I first read this, I had to do a lot of research to confirm it because my mind wasn't really dealing well with the fact that the carbon dioxide weighs 3 times the amount of the gasoline that's in my tank. So it's really, so basically if you've got a 20 gallon gas tank, by the time you burn that tank of gas, you're going to have released around 400 pounds of carbon dioxide into the atmosphere. So the question gets to be then, do you get rid of your gas guzzler? Okay, so thanks to grandchildren, I have a Tahoe, and it produced 35. The carbon footprint just to manufacture it was 35 tons, and every 12,000 miles releases 6.9 tons of carbon dioxide. A compact vehicle is about 1/3 in the initial carbon footprint, and as you would expect, it gets twice the mileage, so it releases half the amount of carbon dioxide per 12,000 miles. So most green people will tell you, get rid of your gas guzzler and get your compact vehicle. The problem is It really reduces your personal carbon footprint of what happens to the old vehicle. If you trade it in, it's still going to be on the road. So what you're doing is you're compounding the problem. You're this like this. If I trade in my Tahoe for a Toyota Corolla, this 6.9 tons of CO2 is still going to be going out the tailpipe, and I'm just adding to it 3.4. So I'm making it 150% of the problem that it is right now. So yeah, so you have to think about that. You know, do you listen to your guilt, or do you do the math and press on with the gas guzzler and just take all the guff that people give you? Um, so another one of my favorite oxys to gore is bottled water. You know, I'm going to start with the bottom. Americans spend almost $6 billion a year for the safest, best drinking water in the world that comes out of our pipes. And yet, we average American consumes 42 gallons of bottled water a year. Going through all of the math of the billions of gallons in the plastic bottles, it's about 104.3 billion bottles of water per person per year, and that's in the United States only. Now, so what's the carbon footprint of that? Well, let's start with the water wastage. It takes about 3 gallons of water to produce 1 liter of, 3 liters of water for 1 liter of bottled water. So you take the 42 gallons per person and the 2 gallons wasted in 327 million people, and we waste 27.5 billion gallons of water each year to produce bottled water. Again, remember, you turn on the tap and you got the best water in the world. It produces 4.2 million tons of carbon dioxide, and that includes all the petroleum to manufacture the bottles, but it does not include the transportation and the distribution system of the bottled water. Again, this is only the United States. So why is that important? Less than 7% of the Earth's water supply is usable. Okay, we got a lot of water on the planet, but most of it is not usable. So we want to be real careful about wasting what we've got. One of the largest reservoirs in the world is the Oglala Reservoir that sits under North Texas and Oklahoma, Kansas, that whole area up in there. And that reservoir is at its lowest level in recorded history because of the number of wells that have been tapped into it to support production of corn, an awful lot of which goes into the alcohol in our fuel and out our tailpipes. Another reservoir that's of significance is the reservoir that's under the Permian Basin. I have this thing about fracking. For every time a well is fracked, it takes about 1 million gallons of water. So each oil well can be fracked about up to 18 times. So that's 18 million gallons of water that is permanently contaminated. And I did the math, and in the state of Texas, in 1 year, about 14 billion gallons of water is permanently contaminated in the fracking business. And the thing is that the reservoir that's underneath the Permian Basin was last recharged at at the last ice age, when the glaciers melted back. So it hasn't been recharged in 20,000 years, and they're using it at a ridiculous rate to send us our gasoline. One other thing about the warming of the climate is that warm air holds more water than colder air, and you can see it goes up pretty drastically. It's not a straight line. It's an exponential curve. Now, what that means is that you've got warm air and more moisture in the air, and when the cold fronts come through with all of this increased moisture, you get these raging thunderstorm fronts that we've been seeing, the swarm of tornadoes, the major tornadoes, and for us who live on the coast, more powerful hurricanes, and generally more of them. So it's an ugly picture. Like I said, I live on the coast, so we pay attention to the sea surface temperature, because when it reaches 80 degrees, that's adequate, that's sufficient to support a hurricane. So we reached 80 degrees this year on, I think, March the 12th. So technically, we've been in hurricane season starts 1st of June, but we've technically been in hurricane support situation since March. So we're seeing species migration as a result of climate change. Both the red and the black mangrove are creeping northward along the coast, both in Texas and in Florida, South Carolina. The red mangrove, the one in the lower right, did not exist above the lower Laguna Madre in Texas 20 years ago. It has now moved north some 200 miles. The black mangrove is also moving north. These mangroves are replacing the normal marsh grasses that we have. Those marsh grasses are required to support larval shrimp, the larval flounder, redfish, speckled sea trout, and blue crabs. And the blue crabs are part of our whooping crane food chain. You can see the prop roots down here on the red mangrove. Those provide some shelter for young fish, but not the proper shelter for the larvae to mature and to hatch in safety. So what we're seeing is we're losing habitat for the growth and maturity of some of our critical seafood. These are three of the species of trees that are moving their range northward and uphill to escape the warmer weather in the summer. At the same time, the lower elevations and the more southern extremes, they're dying out. So they're going. So the range is moving north. The problem with going uphill, of course, is eventually you run out of uphill, and so the species can die out by going uphill. A couple of animals, a lot of animal species, but a couple that are noteworthy is the southern pine beetle has moved out of North Florida and Georgia, is now into the Carolinas and Virginia. Look out, Dave and Nikki, it may be coming for you. And it's you can see what it does to a pine forest. It's just pretty nasty. The Florida manatee that used to exist only in the spring-fed freshwater rivers of Florida has now been found as far north as Maryland, and has used the intercoastal waterway and has gone as far west as Texas. So they're moving about. Birds also are being affected. The northern bobolink effective range is some 20% of what it was 100 years ago. All of these species here are finding that their ranges are moving and they're being affected. Also, the migratory stress is really significant because we're seeing a disconnect between the migratory pattern of the birds and when the the plants are blooming and producing their fruit. The fruit in the spring and nuts in the fall are becoming disconnected from the migratory patterns of the birds. So the birds are finding themselves going hungry as they migrate because their normal food is not there. This website is really pretty neat. You can go onto it and you can check out whatever species of bird you want and find all the ranges and what the effects are. So it's well, if you're a birder, it's well worth taking the time to take a look at that. So God asked Job, "Hey, bud, where were you when I made the world? You know, I made it one way, and you think you can control it. So we need to have a little talk with God and ask ourselves that same question: where were we when God founded the earth? And stop doing the things that God prefers us not to do." So anyway, let's get on to the gardens. So we probably are all familiar with what your climate zone is, what your plant hardiness zone is. There's few problems. One is that the latest plant hardiness zone that you may be familiar with may not be accurate. It also doesn't reflect microclimates. So you need to do some research and check out to make sure you know exactly what your plant hardiness zone is. And the first question you start out with is, what's the last frost date? So, of course, the problem we've got with climate change is that we're getting these sudden, unexpected late season frosts, killing frosts that come in later and later. And it's just unanticipated. It's part of the climate change model, but it's very frustrating for those of us who are trying to garden and get your plants in before it gets too daggone hot. And all of a sudden, here comes this norther comes through, and all of a sudden your little sprouts are all withered up and dead. So have to ask yourself, what's your problem? What are you trying to cope with? What is climate change doing to you? And is the problem you're having this year the same one that you had last year? Or how about the year before? If you don't have a record, if you don't have a journal, and you don't know exactly, you're kind of fumbling around in the dark. But these are some of the things, the more notable things that are happening as a result of climate change. Bad news, slide number 3, there's no white knight, and I'm not going to be able to sit here and tell you how to solve all your problems. You're going to have to become your own best expert. Find out exactly what your plant hardiness zone is, do your homework, research, keep records, and look back and try to figure out what's going on. Experiment and always learn. Couple of points. One is that if you haven't had your soil tested, if you don't know exactly what's in your soil, then you're handicapping yourself. So make sure you have your soil tested and have it tested every 3 years or so, because it changes as you add amendments to the soil. Secret that a lot of folks don't use is your land grant universities. Through the National Institute of Food and Agriculture, part of the USDA, they funded all of these universities as land grant universities. And their mission is to know exactly what's going on in your area and to become a center of excellence of advice for farmers in particular, but for anybody who's interested in growing things, gardeners, horticulturists, and so on like that. And I can't tell you how widespread each university is in each one of the states. I know that in the state of Texas, Texas A&M University has an AgriLife extension agent in every county office. Some counties have multiple AgriLife extension research laboratories and offices with an awful lot of expertise. So wherever you live, find out what your local land grant university is and start digging in with them and ask them how to help you. These are your white knights, not me sitting down here in Texas, but these are where your local knowledge really is, and where you can get a lot of information. So every solution to a problem also generally has some sort of a downside to it. If you use chemical fertilizers, the runoff, particularly in the Mississippi Valley, creates the dead zone that kills thousands of fish. I mean, millions and millions of tons of fish in the Gulf of Mexico every year. And we're seeing dead zones now off of the East Coast and off of Florida from the same type of thing. So be careful with chemical fertilizers. Use rainwater harvesting if you can. If you use irrigation, even if you're using it from a pond or a stream, it does introduce salts and minerals into the soil that impacts the soil, and it's just not as healthy as rainwater for the plants. Mulches, if you buy commercial mulches, be careful. If it's dyed or uniformly colored, avoid it. It's got poisons in it. Also, the ones that say that they're hardwood mulches also have treated wood and diseased wood and paint chips and so on like that. So beware of commercial mulch. And of course, herbicides, pesticides don't care about good or bad. They're pretty pretty broad based. My suggestion is to definitely go organic and find a local organic certification course. Get yourself certified as an organic gardener. And even though the springs, we think the springs are coming earlier and the falls are lasting longer, the growing season may be getting shorter, because when the temperature hits 90, pollinating slows. Soil temperature gets to 85. Strange things start to happen to fruit-bearing vegetables. And at 93, fruit may not set. I know that I have a problem with my cucumbers, in that they because the temperature is 95 and has been for over a month. I get blossoms on the cucumbers, but I don't get any fruit. Turns out that when the temperature is over 93, cucumber produces only male flowers, not female flowers. So it takes a female flower to produce the fruit. So it looks like they're doing okay, but they're not. They're struggling. So you need to do the research and to figure out what's going on. I also discovered that where I plant my vegetables, I have a microclimate, and the temperature is some 3 to 4 degrees higher than the rest of my yard space. So I need to change where I'm going to try to grow vegetables. Talk about rainwater harvesting a little bit. Try to collect only the water. You need to use a first flush diverter. There's some. This is the first flush diverter right here and right here, and that just takes the first runoff from the roof that has dirt and chemicals and stuff in it, and it collects it into a tank, and instead of putting it into your reservoir. This is a pretty impressive physical arrangement here. This one I love. This is just so cute, where you've got this little tank sitting underneath a planter, and he's got an air gap between the downspout here, and there's a screen on top of that that captures the leaves and the little sticks, keeps them from going in. So all he has to do is drain those. These first flush diverters, by the way, you can buy them off the shelf at Home Depot and Lowe's at your big box stores. So you don't have to do an awful lot of hard science to figure out how to make one. And they're only about $30 made out of PVC. This is to me a really ingenious spot irrigation system. A pinhole in the cap, 2 pinholes in the bottom of a water bottle, and there you go. You're doing just the irrigation that you need to, and you're not spraying a lot of water in the air to evaporate. This is a really low tech hack, and I mean, look at the strawberries. It's obviously working quite well. So we'll talk about soil a little bit. Soil tends to pack during the winter, so you got to turn it over. But we'll tell you, you don't want to till, so you don't want to use a rototiller, but you got to get down and you got to work in mulch, and you got to work in leaf litter. You got to add components. You also need to oxygenate your soil. Packed soil doesn't contain as much oxygen as it should. So turning it over helps oxygenate the soil. Our house down in Brownsville has alkaline soil that has a fairly high clay content as well as river silt, and that thing packs down like concrete. When I reach for a shovel, I usually have to take a pickaxe with me to break the surface and to get into it. So I oxygenate some of the soil with hydrogen peroxide. Mix hydrogen peroxide with water and do a mix there, and that penetrates down to the roots, and I can see the results in a week or so as the plants perk up and green up and really like that. Again, soil test. If you don't know what your soil is, it tests out, then like I said, you're kind of handcuffing yourself. If the pH is too high in your soil, you can add compost or sulfur that'll acidify it. If your soil is too acid, you can add some lime. But one of the things that happens with the heat from climate change that most folks miss is that minerals tend to be dissipated as heat increases. So have your soil tested and make sure that you treat your soil with the proper mineral mix that you need for the species that you're trying to grow. Now, if you're doing a lot of different types of mixed vegetables, you may need to do slightly different treatment in slightly different areas of your garden based on what specific species want and like. Mulch, but again, no colored or black mulch. Down in the Rio Grande Valley, the citrus farmers are using this white weed block extensively in place of mulch, in place of hay or other areas. It works really quite well. So they put in their drip irrigation system first, and then they put the white weed block around their citrus trees out to the drip line, and they don't do a lot of other kind of mulching, and it works quite well. Not only keeps the weeds out, but it just helps keep their soil nice and moist. Make sure that your seeds germinate before you start throwing a lot of mulch on there. If you plant seeds and then you put 4 inches of mulch, the seeds have to come up out of the soil, and then they got to struggle through the mulch, and you're probably not going to get a lot of germination success with them. and please no volcanoes around the trees if you choose to mulch around your trees. Most organic folks will tell you you don't need to mulch around your trees at all. In fact, you want to expose the roots at the base of the trunk and let them breathe and see some sunlight and grow bark on them. That's better for the tree health. Consider living mulches. We miss an awful lot of this because we want to pull the weeds out, and then we want to get this nice, rich, composty mulch and put it all around the plants. But consider living mulches. Got to let if you're planting from seeds, you got to let your crop germinate and grow a few inches before you put the seeds in for your living mulch. But there are good pairings that the living mulch and the vegetables actually complement each other and support each other, and they're good pairs. So I've listed a few of those for the common species. Also, some of our aromatic herbs, you plant them around your garden or interspersed with your garden. They'll keep your pests down. Plus, they're also really great to have on your table. So rather than have a separate herb bed, mix your herbs in with your veggies. Most of you know that if you soak your seeds, it'll speed up the germination. It fools the seeds into thinking they've been planted longer. I'm not going to go into sprouting seeds because Dave and Nikki have great tutorials on how to do winter sprouting and have your plants ready to go in the spring. And again, you want to get them in right after the last frost before the heat sets in. And yeah, you're going to have to take the risk of a late frost. Surprisingly enough, the Farmer's Almanac remains probably the most accurate source of information as to when you're going to have a killing frost in your area. I don't know how those people figure it out, but they're right the vast majority of the time. So invest in the old Farmer's Almanac and become an old-time bib farmer. Get your bib coveralls and get out there and get dirty. Just a reminder that you got to disinfect your tools. There's a couple of mixtures for disinfection, and then rinse them off after you get done. Don't just disinfect them, dry them, and then oil them, please. Sharpen them, keep them sharp. My daddy used to tell me the most dangerous tool in your toolbox is a dull knife, and the same thing applies for garden tools. A dull tool is especially a lopper or a pruner is you can do an awful lot of damage to a plant with that. Even though we're talking about drought in my area, overwatering is not uncommon. So stick your finger in the dirt. If it's moist an inch down, you're okay. If it's dry, put some water in there, and drip irrigation is the most efficient. What I learned from the Texas A&M folks a few weeks ago is that most recommended amounts of fertilizer are for an entire season. And if you apply that all at once, you stand the risk of burning your plants at first and then not having enough for them later on in their life cycle. So divide your fertilizer application into 3 separate applications and space them about 6 weeks apart, so that you're giving it equal applications across the growing and fruit bearing life of your plant. And we talked about turning the soil over, but avoid over-tilling because that mycorrhizal fungi is really really essential. But still, you got to work the mulch and the amendments into the soil. you can do an absolute no-till approach and use the garden fork and just lift the soil up a little bit. That'll get some oxygen in there and it'll break it up a little bit. But it's difficult to work the amendments and the mulch in unless you're willing to wait years to have that layer and layer and layer of mulch and compost layers. And for hot climates, plant veggies in the shade. Plant them so that they get some early morning sun and then that they get filtered sunlight for the rest of the day. It's usually the late afternoon sun after 3 p.m. That's the real killing sunshine. Also take a look at where the wind envelope from your house and your trees and your shrubs are. If you have a a western or northwestern exposure, and that part of the garden is protected from the cooling breeze, it can turn into a real oven in there. So to take a look at that in the warm climates. I was asked to provide a list of the general things that you can do about climate change. First thing for me is to vote green. If somebody is an avowed climate change denier, they're off my ballot, and I encourage you to do the same thing. It's reality. So denying it certainly harms us all. For me, keep your current vehicle, maintain it, and drive it until the wheels fall off it. Don't compound the problem, and then when you get rid of it, make sure it goes to scrap. Okay, not to somebody who's going to stick a new engine in it and continue to drive it around and not keep it up the way you did. Walk or bike, that's pretty obvious. Tote your own water. We all have water bottles. Well, fill it up out of your tap. However, some of you may have a sensitivity to chloramine, which is a chemical that's used to provide chlorine and ammonia in water. Some people do have a sensitivity to that. If so, by the way, the chloramine that's used to treated water will etch copper. So if your local area, if you have an aquarium and your local community uses chloramine and you have copper pipes in your house, you're probably poisoning your fish in your aquarium if you use tap water, because it'll leach copper out of the pipes. So if you're sensitive to chloramine, use a reverse osmosis. Costs about $200. In about 15 months, you produce as much water out of your reverse osmosis unit as you would if you were drinking bottled water. Now, reverse osmosis wastes water, remember, because that's what the bottled water people use. They use a reverse osmosis. So you're going to get only about 25-30% of the water. The rest is going down the drain. And the reverse osmosis installation instructions tell you how to put that purge line into your drain. Well, don't put it into a drain. Put it into a 5-gallon water bottle. Get a clear water bottle, kind of like you see in water coolers, and put that purge line into that bottle where you can see it, and then take that water and use it to water your potted plants and to take it out into your garden and do some spot watering with it. It's perfectly good for that. It's just not pure water, and it's going to have a little bit higher concentration of the chloramines in it and more minerals than you would. So you're going to want to use that along with your harvested rainwater to do your watering, but don't let that water go down the drain. Corded instruments for your garden and for your lawn are the most climate friendly ways to go. Not the lawnmower is probably one of the least efficient engines that exists. Uh, so it produces an inordinate amount of pollutants and no catalytic converter. So you're getting all the nasty stuff. Let your lawn grow higher. Um, and beware of batteries. Everybody, I mean, the trend now is to have all these neat rechargeable battery powered lawn equipment. Well, the batteries eventually wear out. Battery recycling is very difficult to find, and it's not very efficient, and disposal of non-rechargeable batteries is really really shaky. So just be careful with batteries. I say go solar if it makes sense. Uh, it doesn't always make sense. Uh, when we remodeled our house in Brownsville, we did a real green job on it. We put in we over insulated the attic, we insulated the walls, we put in low emissivity windows, and the whole works. And we had an engineer come out and do an analysis of our house for solar, and we were told it makes no sense. The carbon footprint of the solar installation and the amount that we would save in power would had a return on investment of about 100 years. And the solar installation, you can only count on it lasting for 10 to 12 years before you have to replace it. So it did not make sense. So make sure that it makes sense if you're going to go solar. But if you're going to go, there are an awful lot of communities in government, local governments that give you incentive grants to help you pay for your solar conversion. Weatherize your home. I won't beat this one to death, but you can do an awful lot by changing the windows and doors in your home. Recycle. Uh, some communities don't have curbside recycling collection. Okay, if you have to take it to a recycling center, so be it. But recycle. And the last is support environmental activist groups, or become one yourself. I mean, get out there and get a sign and march up and down the streets, and do what you can. A lot of the organizations do volunteer work in gardens and in wilderness areas, but participate. It's good for all of us. And so this is how we get to the name of Warriors of the Rainbow, the Hopi prophecy. When the earth is ravaged and animals are dying, a new tribe of people shall come unto the earth from many colors, classes, creeds, and who by their actions and deeds shall make the earth green again. They will be known as the Warriors of the Rainbow. So for us, the job is to go make the earth green again and all become warriors of the rainbow. So the last slide is of Glacier Bay. This is the John Muir Glacier in 1954 and 2024. Same mountains. You can see the same mountains in the background. So that's what's happening in Glacier Bay. I want to thank Renee Brown, Texas Master Gardener, for her contributions to this presentation. And thank you, Nikki, for asking me to do this.
Oh, thank you. You're so welcome. We're so happy to host this, and I've put the slides of the talk this evening on the chat. It's definitely a lot to ponder and a lot to think about, how even if we just do one small thing to change whatever current, we can all improve in one small way. I think it's definitely sparked a lot for me to oh yeah, that's something I could do. That's something we could do. So thank you so much, Stephen, for being here. And we'll open it up for any questions people have this evening. I didn't see anything in the chat, so feel free to unmute. We're only a small group here of 8, so if you had any specific questions for Steve.
I had a question about if you've looked into like carbon sequestration and whether we can make a positive impact. You know, if you have like a large lawn or something, the amount of carbon that you would sequester versus if you covered that with trees and plants and things like that.
Uh, yeah, I haven't looked at that specifically, and that's one of the problems down in our neck of the woods with the black mangrove the mangrove migrations, both black and red. They're a great carbon sump. I mean, they're much more efficient at pulling carbon out of the air, and as they grow into their mangrove thickets, they really do a great job of capturing carbon, much more efficient than the marsh grasses. The problem is, of course, that they're supplanting the marsh grasses, and the downside is that the sports and marketing fish and shrimp and crabs are losing their populations. So, but no, I have not looked at carbon sequestration of trees versus lawn, but it kind of intuitively, I can't give you any numbers, but it's kind of obvious that if you go to trees and underbrush, that it's going to capture a lot more carbon than a lawn does. Um,
Do you find in your climate, so we've visited Phoenix in Arizona, and there's just poor land usage there for what the climate is.
mhm.
You also experience that kind of like if people just use the land appropriately in your region, that could also make like a big difference. I don't know much about Texas, but I was just wondering if it's similar to Arizona.
Well, it's different primarily because of the humidity, um, uh, uh, and um, we have an awful lot. Some of the similar problems. A lot of our agricultural uh, areas down here um, are irrigated by water out of the Rio Grande River. They try not to use the well water for two reasons. One is that they they want to keep the well water for human use, for use in their homes. They don't want to use it on the crops, and because it's less expensive to buy water out of the Rio Grande. But as I mentioned, that has the problem of adding minerals in the soil. So and the salts build up, the salts from those minerals, and it's not like table salt, but it's various types of salts, carbon and magnesium and calcium salts that build up in the soil, and that causes productivity to drop off oh up to 30% of a citrus crop, and the leaves yellow, and the trees just aren't as healthy, uh, and so that's one of the type of problems that Arizona has too, because they do a lot of their irrigation out of the Colorado River, which has the same type of mineral content that we have in the Rio Grande, because the Rio Grande starts up in New Mexico, so it has a lot of mountain area, but that's some of the same type of thing. I note that in California, that what they're starting to do is, since they have a lot of their water that's brought by to particularly to Los Angeles by canals that are open, is they're now starting to enclose those canals and cover them with solar arrays, so that not only is the evaporation of the water in the canal effect. So uh, uh, I don't know if I answered your question, Dave.
Yeah, yeah. And I wanted to thank you also for your presentation was chock full of information. So thank you very much.
Yeah, that's why I wanted to make sure everybody gets a copy of the presentation, because there's lots of data in there, and hopefully if you have any questions, you can dig into it more, because it's just sort of food for thought. I do a presentation on climate change that's got a lot more number crunching in it, and it can make people's eyes glaze over. So, yeah.
No, this is very good and very practical. So thank you very much again, Stephen, and thank you everybody who's been here. I'll have the recording for this for everybody, and including you, Steve, and it'll be up on our YouTube channel. So once again, I hope that this has brought the awareness and also like the impetus to do something about climate change, cope with it, yes, in our gardens, and hopefully change the climate for the better instead. Thank you. Thank you so much, and have a good night, everybody. And Steve, we'll be in touch with you. Thank you.
Okay. Thank you.
God bless.
Thank you
Bye.
so much. Good night.
Bye. Good night.
Hey.